Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, integrating mainframe observability with your APM solution, brought to you by Software Engineering of America. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to watch it again. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinars, and it will be available for you as well. We are taking questions from the audience throughout the presentation. Use your webinar interface to submit questions into the Q&A section, and we will try to get to as many as possible at the end. We also have a few polling questions during today's event, so we'd appreciate it if you could take a couple of seconds to submit your answers when you see those come up on your screen. Finally, stick around at the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. Joining me today is Alfredo Perez, a product manager, Software Engineering of America, and Jim Morgan, director of sales, Software Engineering of America. And with that, I'm going to put myself on mute, turn off my camera, and let you get started.
Thank you very much. Good day, everyone. It's really great to be here. For the better part of the last 25 years, I have been working with organizations around the world, helping them evaluate, deploy, and get results out of build automation tools, testing products, and reporting capabilities. By far, the biggest successes and the most I have learned has been having the privilege in working with my customers. In fact, part of what we have been spending a great deal of time on in the last 5 to 10 years, but consistently throughout our history, is investing in modernization, in walking the walk and taking assets that are proving them and enabling them to be used by the enterprise. And these assets, in our case, are primarily mainframe assets. I would like to kick off this conversation by saying that I'm here to learn. I'm going to talk a little bit more than you probably. I would be delighted to hear your feedback, your questions, critical analysis of what we have to say, and responding to our survey questions. If you have other comments, please post them. And I'll commit to you that I will get the results of any questions we ask out to the team, the attendees that are joining are with us today. So with that, let me jump into our introduction. What I'd like to do is to start our visit with some assumptions about the viewer that might be most interested in the content that we have to discuss. I'll then jump into some observations about what my team is seeing as we work throughout the customer base. Some of them we've been together for a number of years, observing what customers are talking about and what they're doing, and then to talk about some of the outcomes or the consequences of what they're seeing today based upon their activities. Before I jump into a summary or a takeaway and turn it over to Alfredo, what I'd like to do is spend a few minutes discussing the mainframe culture, especially for new stakeholders out there that are in IT, to share some insights that might help in engaging folks by walking into a conversation, not assuming that things that you necessarily believe or the frame of reference that you have is exactly the same as your counterpart in the mainframe world. So with that, what I'd like to do is get into assumptions. The first is our viewer is either interested or is actually engaged in supporting an application portfolio that is multi-tier. It might be, for example, a web front end that's issuing a request to a Java application running on a Linux server, and that Java application is issuing a request to DB2 on the mainframe. And this communication is then routed back to the requester as part of the delivery of the services across tiers for that application that's running. Our listener, our viewer is engaged in modernization. It's a topic where your organization is investing to drive higher quality, accelerated velocity to quality delivery, and there are changes going on in the environment. You might be working on a shared culture that's articulating values around a scaled agile framework or perhaps DevOps practices. But whatever you're doing, what we're seeing are consistently themes that are coming up with customers as we talk about them. First is reusability, and I also frame this with common services. It's this idea that's as old as agile methods, where you're refactoring valuable assets and you're making them highly accessible to requesters. You're interested in testing. A fundamental precept of modernization of this DevOps practices, scaled agile framework, is highly predictive and accessible testing. In fact, to the point where the ideal state is where your test environment would be predictive fully of what's going to happen in production. Common tooling is an interesting topic, and it's often brought up when I visit with customers and talk about what priorities are. One of the interesting things is there's a difference between common tooling and common services, and the latter is probably a lot more interesting way to achieve common goals. The one constant is change. And if you're adopting, you're involved in change. And the other constant is probably where there's change, there's resistance to change. If you haven't been working on it now, I'm sure you're dealing with drawing adoption of new environments, new interfaces, new tools. It's a really interesting area, and it's a very important one, and it serves organizations well to be thinking about that up front. There's not a whole lot more I can say about metrics and measurements. It's almost self-evident that you have to measure to manage. The interesting thing, though, about metrics is they are fundamental with serving goals such as measuring adoption, process return on investment, and they are a fantastic nuts and bolts negotiation tool as you work with different stakeholders to negotiate outcomes. If you're promising improvements, you can show them trends and metrics. Let me pause for a second, folks, and if you would indulge me, could I have question number 4, please? If you would take a look at that and let me know briefly what you think. Okay, so we've got not a lot of responses, so we'll go for 1 or 2 more survey questions, and if there's not an interest in these, we'll continue with the presentation material. Let's get into. Oh, by the way, I will answer the terms, and the question was for multi-tier applications. How often are application issues first identify a business consumer or customer interacting with a web UI? So your customer is basically notifies the support group that there is an issue. And of the responses I have, we've got 10 so far, 3 never, 5 infrequently, and 4 frequently. So as a percentage of the responders, we've got 4 out of 13. So the number's 25, 30%. And please continue to answer them. Don't be shy. So let's talk a little bit about what we're seeing. The monitoring and observability gap. The idea with this concept is that monitoring tools are basically, as I interact with customers, more geared toward measuring the state of the services that are available for applications to consume. Where observability is more about the specific services across platforms that an application is consuming as it is performing. So it's a view of services that are consumed regardless of platform for an application or a business service. APM supporting problem incident management. Folks, this is a really interesting area. You probably can see by these terms that problem incident management are service management processes that are really common, for instance, in ITEL, and they're assuming that the work is being engaged in a production versus a test environment. Decision support based on non-current metrics. I'm observing this more, folks, in the Z world, that it's this idea because of volumes, primarily because of volumes, that what we find is customers that are doing observability in Z are not infrequently basing observations on aggregated data and a historical point either 30 to 60 minutes before or 30 to 60 minutes after the event. I'm not discounting the value of history. Alfredo is going to get into things like time series databases where historical and aggregated data reporting is important. As of now, what we're seeing though, primarily as we talk about APM and Z, it's not real-time data yet. Vendors are attempting to protect their position through proprietary enhancements. I'll come back to that. Functionality gaps by platform. We're basically seeing, especially in the area of monitoring, that tools that have been invested over years that are very rich, have years of intellectual capital, were designed primarily for a specific platform, and they perform that function very well on that platform. The challenge is when folks are starting to branch out, or when folks are starting to think about monitoring capabilities and applying them to observability. They're two different areas, and Alfredo will get into this. Resistance to replacing high-value assets. I'll talk about that a little bit more later. And adoption to resistance of new and experienced users. Can't understate this, that if you are well down your DevOps journey or your modernization journey, you are now looking at, I'm reasonably sure, the topic of adoption and making choices about promoting common tools and platforms in the context of drawing user interest. So before I get to observations and turn it over to Alfredo, let me share a couple thoughts that might be real interesting or might be interesting to you. First is that the experiences, work habits, paradigms of build and run stakeholders, especially in the mainframe world, they're unique. Everybody is interested in high quality and responding to changes in the business. If I'm a service management practitioner that embraces ITIL, I'm relying on a release schedule, which is time-based. It's not intuitive to me that change review and change approval are automated processes. Whereas an agile developer is looking to make investments for great testing to get to a point where you're doing continuous delivery. So on the face of it, when you're talking to a stakeholder in a different group, don't make assumptions that although their beliefs and eventual outcomes of the business are the same, the pathways to get there might be different. And that it works itself out through conversation and negotiation and collaboration. Investments in infrastructure, this is key in the mainframe world. Common tools, common process, cost-driven efficiencies and standardization are basically table stakes. If you go in and talk to a customer in a mainframe area, before you even get to value, along with that, there's going to be an expectation that cost elements need to be addressed. And finally, constant pressure to limit the number of suppliers. I'll talk about that a little bit more in a second, but it basically combines to bring some interesting outcomes. Let me do this, if I may. Speaking of paradigms, could I have question 2 and then follow it with question 3 up in the poll, please? So application performance management, typically finding it's done by development stakeholders. However, the monitoring and the performance management is based upon work running in production. In your environment, is this a no-brainer? Is this owned by development? Is it owned by operations, or is it owned by a different group? Yeah, overwhelming. Folks, thank you. I'm really getting enthusiastic responses now. Overwhelmingly operations. Let's see question number 3, please. This is a really interesting one, folks. This term is emerging. It's more prevalent in non-mainframe organizations, but it is huge. The site reliability engineer is probably one of the key folks that are going to be involved in establishing SLAs and measuring SLIs and measuring SLAs. Where do these folks fit in your organization? Okay, there's some ambivalence on this. We've got a mix. We've got operations, and then equally we have neither and don't know. The folks that don't know or aren't sure, you're not in a unique group right now. It's what I'm seeing is an evolving practice. Okay, folks, considerations for priorities going forward. The point, if you're looking at that picture, it is black in its white. It's the same dots. But if you look at it closely, it's likely you're either going to draw an old woman or a young woman in your view. The point is if you're advocating change for observability, you're already sold. It's going to be really important to really invest time to fully understand the perspective of other stakeholders that you're going to need to syndicate to get the results you want. This is especially true when you're talking about observability across platforms. Common services versus common tooling. Again, this to me, could very much be a perception. And one very short example is in testing. I hear commonly that folks need to have they have to have standard testing tools. So the modernized testing tool utilizes an Eclipse plugin where the mainframe stakeholders are using a great tool through a green screen. The answer to the question, if your vendor is really buying into modernization, is not common tools, it's modernization and making these tools services that are available. If you're doing that, your Eclipse users are using the same service, the same testing service as your green users. So folks that are getting hung up on the common tools as a standard and facing challenges on a number of areas, consider revisiting what common services might mean in addressing that. APM needs to be engineered for near real-time diagnostics. The one thing, again, I guess the second thing constant in this world that we're in is constant improvement. I guarantee you that the involvement of APM and observability, as it has to do with mainframe and other platforms, is going to demand more and more closer to real-time analysis, point in time of what's going on. Well, what does that mean? What that means is that your architecture considerations need to anticipate a constant growth and scale as data volumes increase and the amount of data grows. But it's absolutely doable, and Alfredo will be talking a little bit about that. The final thing is in this idea of with constant improvement, I mentioned that APM, at least as I dialogue about it, is more associated with a production environment. Shift left, DevOps practices, agile methods are all looking at perfecting your testing environment to the point that it approaches nearly 100% predictive outcome of what's going on in production. I don't think we'll ever get there. The idea is we constantly need to move closer and closer. So my question here is, the statement is this is a tremendous opportunity. And the question is, what might APM look like as you move it more from a production discipline, more and more to a test discipline? And the possibilities are really, really interesting. With that, and before I turn it over to Alfredo, I'd like to poll the last question. Okay, I don't have the results up on that, but when I get them, folks, I'll share them. With that, I'd like to turn it over to Alfredo. Thank you.
Thank you, Jim. Can you hear me well? Let me do a sound check here.
Sound great, Alfredo.
Thank you so much. Thank you, Jim. That was great. Well, good morning, everyone. What I would like to do now is to do I will follow 3 steps. The first one, I will set the stage and discuss a little bit about the observability paradigm, this new buzzword that we are hearing a lot in the modern day of our industry, observability. And then I will present our technology offering, how to tackle the IBM C, how we can close the gap of IBM C observability, being mainframe and system C, one of the most important players in the top in the industry. And then I will present a short demo where we can Angelica Hedrick, product manager of our solution named C Iris, will present pre-recorded demo to show some of the advantages of how we can close this gap. So this slide, I will start talking about observability. And again, as I said, it's a bit of a buzzword nowadays. And rather than come with a definition of observability, I like to make a reference of one of my favorite authors that said that when things are very concrete, a definition may be acceptable, but what sometimes we accept as a definition, I better call it an approximation. So what I'm trying to what I will try to attempt today is to get an approximation of what observability is, rather than come with a hard definition on observability. Uh, if you go to Wikipedia, we can find that an entry that says that observability is a measure of how well an internal state of a system can be inferred from knowledge of its external outputs. Now, this is not a new concept. It's a concept that was introduced more in control system industry, and it was introduced by Hungarian engineer, American Hungarian engineer named Rudolf Kalman. And it's been used a lot in control system instrumentations and control systems. And basically, as its name implies, observability is the ability of a system to be observed. Thus, if I have a complex system that I could be represented as a black box, if I gather data, or what we hear a lot, telemetry, from it, we can infer in many areas of its internal state. We can see that. I mean, I like auto racing, and you will hear that this word telemetry was before races. All these you collect a lot of telemetry data that is used to set up your car for the race day. That can be tied to what an observability process is. I like also to bring this analogy. I'm a long distance cyclist. And when I started a long time ago, I used to have these cycle computers that is basically wired to my wheels that can display a couple of variables. But nowadays, we have these cycle computers that can measure tons of data that can help to understand some of the complexities of my body. So with FTP rates, pedaling power, and so forth, I can have an idea. So when I plan a long tour, I can set up my conditioning training, analyze routes, and lots of things that helps me to achieve my goals. Of course, this is more complex than that. This is just an analogy. So what is monitoring? And then monitoring is what we are more familiar with. Monitoring is about looking up for things that I know could go wrong. So we are familiar if I have a metrics on percentage of CPU or throughput, database buffer pool. These are type of indication that something could go wrong in my system or in my application or a service. So this has been working well for monolithic system, but because you know well how a system may fail in this monolithic system. But as systems get more and more complex, the complexity of the systems, and we see now not only from its architecture standpoint, but also application written in many languages, polyglot application, microservices, cloud technologies. The concept of monitoring is falling short. So we may now face some sort of problems that are anticipated but are unexpected. So I delivered a webinar recently and also mentioned that I attended to a presentation on AWS and with the famous H3 object service storage service comprise more than 135 microservices working together. So it's almost impossible for a human to look up all those interactions and predict every failure. So what we could do about this and what we're trying to do about this is is to collect more data that is coming from those unexpected errors, and we have ways to analyze it and figure out why that may be happening. As I have this quote here, the DevOps Research and Assessment DORA research shows that a comprehensive states that a comprehensive monitoring and observability solution, along with a number of technical practices, positively contributes to continuous delivery. So basically, in short, monitoring gives some software team instrumentation, which collects data about systems and allow them to quickly respond when error occurs. As opposed to observability, on the other hand, is the practice of instrumenting those systems with tools to gather actionable data to provide not only when an error occurs, but more importantly, why. And I think that basically give you an approximation of what observability is. So observability is based on these three main pillars that we may be familiar, and we are familiar probably, are logs, metrics, and traces. With these pillars allows you to bring better visibility into systems. Logs, I think we're very familiar with logs. It's basically with logs we can get insight and do more forensic analysis when something happens. And currently logs are, in reality, are immutable records or discrete events that can happen in an application or in a system. And nowadays we have lots of technologies capable of ingesting that logs into visualization, search, index to find a specific analyze a specific situation of a system or an application. Metrics is the foundation of monitoring, and metric consists of measurement that are aggregate over a period of time. So as we talked earlier, CPU percentage, average throughput, and average response times. Now, traces, I think, is the most important one within this observability dimension. And traces, or sometimes called distributed traces, came because of this complexity on application on how error cascades. So traces help us to identify those type of situations, those type of circumstances. For an individual transaction or a service request, a single trace displays the operation that is moved from one node to another in a distributed system. So it basically helps you to detail the entire workflow of a service or a request. So I think that's give a very good big picture of what observability, the new paradigm of observability, and how I can move on and explain how we can make and what's the IBMC roles within this observability dimension. Before doing that, a second, it doesn't move my screen. Why? Next slide. Okay, got it. So before that, I just want to touch on a couple of slides. A trace. So we talk about a trace, and I put these sticky notes here to represent a trace. And you can see a trace as a Gantt chart, project management. And I put different definitions, different ideas of what a trace it is. But what I like the most is that tracing tells the story of a transaction or a workflow as it propagates through a system. That's the definition that I like about tracing. And of course, trace is a representation of series of causally related events or distributed events, and describe the span of time used to perform a process triggered by a transaction or a service. So that's tracing, and this is one of the most important pillars when we try to instrument and try to make a system observable or to empower systems or my application within this new paradigm. My slides are okay. This is an example and this is a screenshot of our technology solution, and we can see here representation of a trace in an APM uh, uh, front end, and we can see this is a database service request. We can see the lifespan of this request, and we can start seeing the story, what happened when I do the connection, what SQL statement I'm trying to execute, how I lock a specific database object, and if something, a problem arise, in this case, this is a deadlock, arise within this service that can help us to identify proactively um, um, a potential problem. And also, the most important thing about not only traces is when we try to implement or instrument these situations, we also need to have enough metadata to that complements, and we can identify and dig into more specific uh, dig more into a specific problem. Now, OpenTelemetry is something that I would like to talk before I move on. And OpenTelemetry basically is a new framework. It's an existing new observability ecosystem with a number of leading companies behind it. This project was created by two merged projects, the Open Census and Open Tracing. But why we need OpenTelemetry? What as we discussed earlier, the complexity of application and services. OpenTelemetry offers a standardized way of instrumenting our systems and doing traces. It basically is vendor agnostic, and it offers a set of a good framework of collections of API, SDK, and tools to create and manage telemetry data, such as traces, metrics, and also logs. Um, One of the interesting thing about OpenTelemetry is that it allows you metadata propagations and also um, provide also an open standard convention and for an end-to-end implementations uh, of implementing traces. So this is very important in the industry. APM vendors are adopting more and more and more these standards, and there's a link here in the presentation where you can find more information about OpenTelemetry if you're not familiar with it. OpenTelemetry.io. All right, so this is an intro to or setting the stage of what observability is. Now let's talk a little bit about IBMC and what's the gaps and what are the problems. But I'm going to try to be brief. This is some ideas that are placed in this slide where we can see the problems that the IBM, the mainframe IBMC in this case, represent the problems in this dimension with the IBMC. But what we need to acknowledge, and this is something that is a fact, is the value of the mainframe within this new way of producing and delivering applications. So for more than 20 years now, the mainframe has gone into a very, very deep digital transformation as well. So we can integrate it more into this new end user middle tiers connectivity, basically to do what mainframe do better or do good, which is managing large amount of data, security, and the resiliency of the mainframe. So we've seen now is very we've seen now the current circumstances with the pandemic, with the COVID, that this also has accelerated the digital transformation and basically in how companies are interacting with their users. So this is where observability comes really comes relevant. We see now that even restaurant delivery, even myself, I'm a volunteer for a nonprofit organization on art. The last year, we spent a lot of time trying to reorganize the systems to provide, better end user virtual experience. So it's imperative that we must have a level of system resiliency and customer experience that is extremely, extremely high. So observability could be seen as an associate discipline to make sure that all the systems and application are producing the right data available in an early development lifecycle, as Jim mentioned in his introduction. Also enable collaboration to solve problems. These are different problems. I'm not going to go through all of them, but just leave that in this visual. Okay. Now let's want to briefly talk about how we close the gap with our technology. Our technology is named C-Iris. C-Iris basically is a real-time framework, near real-time framework, let's call it like that. That's how it calls. That enables mainframe observability in APM and other analytic tools by creating traces from its source. In mainframe, for those that don't know IBM C mainframe, the main source where what that mainframe creates and generates performance data is it calls SMF. So we can see our solution, our technology solution in 4 different layers: the client layer, I would call it the decoupling layer, the server layer, and the front end layer. At the client level, our technology is written using a modern collector or client technology. We use Java. So for those that don't know, mainframe normally base their licensing and processing capacity. So writing a client using a special processor allows us not to impact your cost structure. So this client runs on a special engine on the mainframe that collects performance data from memory in almost, as I said, near real time. This data can be streamed to a middleware, streaming middleware, in this case Apache Kafka. And basically Apache Kafka allows to decouple this data, and we store that in its original raw format in one Apache cluster. And this is basically more for resilient fault tolerance and also for horizontal scalability and high performance. Then we have the server side. On the server side, what we do here is the data is processed from the raw records are processed and turned into traces. This this layer works on a Linux. Our server sides work on a Linux distribution, and basically we organize data in a proper context and make sense, and then we propagate it using OpenTelemetry, or we can also support a specific dependent traces for each APM. We can also do that, but we can propagate data to an APM tool, and this APM tool can run their instrumentation or correlate their mainframe data with their actual dashboard and visualization strategies. Okay. The important thing is that our technology is vendor agnostic, so we produce these OpenTelemetry traces that can be fed into any, not only APM tool, but analytic tool in the front end. As I said, some APM vendors still uses their own agent to manage traces, and the technology, the server technology is flexible to customize and generate a specific product-dependent traces. The server can also work as a cluster. It's helpful to manage large volume of data and throughput demands. Now, this is in a very big picture of what is our technology. here is another slide before I move into the demo, is that we also can load this data into a time series database for any analytic purposes. So out of the box, we use Influx DB from Influx Data, it's a time series database, and Grafana, but it can be any database or visualization tool can be used to also store that data that we stream from SMF, from the mainframe. This is an example of Grafana, different dashboard using that metrics. Now, mainframe SMF offers tons of data, an immense world of data that can be used for different dimensions, and allows us also to correlate any type of events within your visualization strategies. So what I will do now, I think I'm going to, oh, sorry, there's one more slide here. This is an example of Instana. This is the IBM APM, where we have some cases that customers where we create a specific, using the specific Instana agent to manage the traces. So not using OpenTelemetry. And for each case on each situation, for each situation, we have a team that analyzed and assess and all these needs, and we can transform the collected records into a specific traces using for APM agent. Not only that, but there are companies also that are interested in creating standards ways of storing their data, such as using Elastic as a, this is some examples that I have heard, using Elastic, where they can store a common and standard way of storing data from different systems, and that is the main focal point to be used by the APM. So that's also is achievable, and that's the interesting thing about our technology, is how open, the openness to be adapted, and you can instrument any situations within your visualization or analytics strategies. So I'm going to stop here. I'm going to switch to a quick demo, and we will show CIRIS in action, and Angelica will review some specific examples that are very interesting. At the end, we'll come back with some final thoughts and questions, and we'll wrap it up. Let me play the...
We're starting off with Jaeger today for one or two reasons. One, I like this view. I can give a great software architecture overview of what I'm demoing and not just showing traces. But also Jaeger is an open source tool, and it uses OpenTelemetry. So as Alfredo mentioned, OpenTelemetry is a observability framework that's being rapidly adopted by the IT industry globally. Many leading IT companies are involved in this project. And since its GA release in January, there have been rapid adoptions by many APM vendors. I'll just show you the list, at least on the OpenTelemetry website. This is in all the APM vendors that support OpenTelemetry. I'm sure if you Google OpenTelemetry and your APM tool, you may find some information about your enterprise APM support with OpenTelemetry. But back to Jaeger. Today I'm going to show you a few traces that come from various applications across an IT environment. And what I have here on the top, I've tried to sort of separate them. These guys here on the top, we have some online services, online banking, HR Online version 12, another HR Online in a different version, and a banking HR app. These are all distributed client applications running web services, supported by, among other things, Java applications. And these client applications rely on mainframe components. And what I like about this view here is that it might not be completely obvious, because we're not sort of separating mainframe in a little box somewhere where you have to click away and find it. It's all here in this view. And we can see that these client applications have relationships with mainframe in two ways. There are two applications here that use ZOS Connect, and that means that they call REST API services, and ZOS Connect acts as a REST API gateway and transforms and does various activities and passes on the request to a backend. And the backend can be many things. A mainframe, I'm sure many of you know that are on the call today, but among other things, it could be a DB2 server that's processing the requests directly, or it could be a batch job. So this is a WOLA, that's the abbreviation for WebSphere Open Local Adapters. So this is actually a batch job that's processing the REST API requests as well. And then we have two other applications that have direct communication with DB2. And how they do this is with JDBC. So they don't have a KIX or an IMS in between. They're using the Java JDBC IBM driver and connecting via TCP/IP to DB2. And one could imagine that could be very difficult to monitor. If a problem occurs and you don't have visibility into your mainframe, all you have is maybe some network time and an error, a 404, for example, without any real information about understanding what happened in the backend. And that's what we're hoping to solve with our solution. So I'm going to jump to the traces. So in this case, we're going to look at HR Online first. And HR Online, just to remind you, they call REST API services via ZOS Connect. So let's have a look at some of those services here. We can see some activity up in the top. So Jaeger gives us sort of like an activity heat map of all the different REST API services being called. So here we see HR Zcon 1, employee update, and other demo services are being called from this application. And if I drill down into one of these traces, we also get a span map, so a trace timeline. And we can see where time is spent during the request. So here in blue on the top, this is all the HR Online clients. So this is like the distributed application side. We can see that we can see various data, metadata about the process on the distributed clients. And this is all delivered by the OpenTelemetry agents. I'm sorry, I'm just going to click into it. So we can see various metadata. We can see things like the IP address, the agent that was used. We can see the status code. We can see thread IDs, etc. And then what we also can see, I'm just going to close all of these now, is what's happening on the mainframe side. Oops, I lost it. Oops. Okay, so what we can see here is what's happening also on the mainframe. So we can see there is a request that flies over and it enters ZOS Connect. We can see that the ZOS Connect registers the client IP. We can see what method ZOS Connect registered for this request, the bytes, the number of bytes that were received in the request and sent, the code, the return codes, and we can also see which ZOS Connect server and API processed that request. So we can see some things that are more mainframe oriented in this case. So the configuration directory in Unix system services, the server token, the version of the ZOS Connect server, the address space, job ID, the address space name or job name, which sysplex and which LPAR. And this is all in a single view. You also see how much time the request spent in ZOS Connect. So going through the gateway and the gateway waiting for a response from the backend. And we also see how much time was spent in the batch job. So in this case, this request, this employee update service is processed by a batch job on the mainframe. And we can see the time spent within batch job compared to the amount of time on the ZOS Connect tier. So we know that the most amount of time spent on mainframe is spent inside this batch job. So if I was going to look to optimize the performance of this application, I probably would first look at the batch job, because this is where I'm going to get the most win. We have also some identifiers here on the mainframe for the mainframe batch job that services the ZOS Connect request. This is also great. Why do we do this? So you know, we're building these traces for DevOps teams, not just mainframers and DB2 specialists or ZOS Connect DevOps or Ops teams, but also your DevOps guys, your distributed teams. So we want to make sure that they have access to all the information about that service, because that's their responsibility, right? The DevOps teams and the application teams are responsible for their own services and applications, and they want to know where time is spent. They want to know what their dependencies are. They want to start being able to draw correlations between behavior, being able to ask questions. What did service A and service B have in common when they both experienced the same error? So having this kind of metadata in view and in context of the distributed service or the business service is already a big win in terms of DevOps. Let's have a look at the DB2. So let's have a look at the application here. We have an online banking app, and it does pure JDBC calls against the DB2 database. So in this case, JDBC is interesting in many ways. One, it's easier to connect to your databases. Also, there's a lot more Java developers out there, so that's why we do tend to see an increase in JDBC application development. And in this case here, we're seeing something similar. We're also getting some web traffic. The web traffic is serviced by a few distributed applications. And we see that this application performs a few JDBC calls, and it has specific response times, and eventually the request ends. And what we also see is some additional data here in the form of tags. I'm just going to scroll down a little. I can see the net peer address that is registered by DB2. So this address will correlate with the address of the JDBC application here. So, and what else do we see? We see some other great performance metrics. We can see how much ZOS CPU time, so that's all the CPU time, including DB2. We can also see how much CPU time on mainframe was consumed in DB2. So we can compare how much CPU or how expensive these requests are in and outside of the DB2 environment. We can see client user IDs, which is great if you need to understand what effect changing user ID access might have, and also just monitoring your security configuration. We can see elapsed time, so I'll just highlight this here. And elapsed time is the time the request spent in DB2. So we can tell by this tag as well. So we can see it's ZOS.db2.elapsed time, right? So this is the time it's spent inside the DB2 system. We can also see the response time, and response time is normally larger because response time includes the time DB2 waited for the client to respond or to end the transaction or to send another request or network response, etc. So maybe even comparing elapsed time and response time is also letting us know where are we spending more time. Is the client and the network wait time greater than elapsed time, or was elapsed time equal to or near to response time? We know how much data is being sent out in the forms of size. We know if stored procedures were activated during these requests. We also know if zip was used. And in many cases, you may expect your zip time to have been used. So if it's not, you could begin alerting on JDBC requests that have 0 zip time and trying to find out whether you have insufficient zip capacity or too much load for example, and understand how you could alleviate that situation and reduce the costs of your JDBC architecture. Another thing I want to show, and I just don't know if we have enough time, so guys, just stop me if we don't. But I wanted to talk a little bit about the curious case of HR Online version 12. So you can see it's basically this app. It's just a new version, very few calls. And I'm going to demonstrate this in another APM just to show you the vendor neutrality of this product. And here you can see it's HR Online version 12. It's doing the same thing. It does the same service request. It's also using JDBC. The customers complain, in this case, they're complaining that when they do use the new version of the app, it's either slow or it starts to have errors. And so that's why they don't use it and they just keep using the old stuff. And so if we wanted to understand what the problem was, we would use the APM tools to find out where the problems lie in that service. And what we can see during times that we have errors is there are two services that run specifically in those time slots. And if I look at the two services during the time of the error, I can see one of them has an incredibly high latency. So I'm just going to look into this and try to understand what the issue is. So I do apologize if the network response is slow. So I can see the call coming in through the web server. I can see the connects coming through on JDBC. So that all seemed to be okay. But then something weird happened here, and this application tried to do a lock, which should have worked. It was just doing a lock. It tried to have an exclusive lock and waited a really long time. And according to the this sysout here, or like the log, you can see it just says a connection failed. Client reroute environment. And I guess in many cases here, the DevOps teams or the application teams are going to consult their mainframe teams and ask them to stop please pulling logs and find out if there were any other existing errors during that time. But because we have Ziris, we can see two things. So we can see DB2 accounting. We saw that already in Jaeger, but we also see something else that's really interesting. We see that this application was actually affected by a deadlock, which kind of now for me explains why this lock was unsuccessful, because I was deadlocked. I was waiting for another resource to give me access, and he was probably waiting for something I'm doing on the other database. So now I don't need to bother my team. I'm like, okay, great. And I can also find out which other application it was. So I'll just open up another tab for hopefully simplicity. So I'm just going to open up the Analyze dashboard here, and hoping it'll come up fast. Okay. So, and I'm going to look for the application, and how I do that is, I probably went over that too quickly, but every application request or call has some sort of ID and identifier. We know this in mainframe. We know these as transaction IDs or correlation IDs and things like that, right? So that helps us to understand which events are related to each other in terms of a service. And what I want to do is try and find the application with trace ID, that. And so all of these requests here are related to the application with whom the other application deadlocked. So I could click on any call, it would take me to the same stack. And here I've already seen, okay, I can tell which service it is. It's within the same application. This is also the same HRV Online 12. Here we can tell. We can see that there were other calls being made. There was another lock tried. And here we can find even more details about the deadlock. Information about the DB2 system, information about the DB2 resources involved, and all types of other details that may be helpful in trying to prevent a future deadlock within this application. For example, seeing lock behavior, any stored procedures that were activated that may be aggravating the deadlock, and much more. So here we also see saving time, getting faster to finding root cause analysis. So we know it's a deadlock, and also helping the teams reduce time to restore application availability.
Thank you so much, Jim. I'm going to pass it to you.
Alfredo, thank you. Angelica, thank you. Folks, thank you so much for joining today. Your attention, your questions, your responses quickly on the question around challenges. We got 28 responses. 16 of them either are trying to formulate or having difficulty with business case formulation, identifying leadership or sponsorship to engage on the topic, or architecting the solution. They're all challenges. 14% are just starting to invest. 3 are doing great. 11% said they're doing really good in this issue. Congratulations, folks. Alfredo, Angelica, and I are all on LinkedIn. Reach out to us if you'd like to connect. If you have any questions, we will absolutely respond. Since we're at the end of the hour, I am going to end our visit. And on behalf of my team, thank you, everybody, for joining. Take care.
Excellent. Thank you. Just as a reminder that today's webinar has been recorded, so if you missed any or all of the program, you will be able to watch it again. We will be sending an email with a link to access the webinar on demand. The webinar will also be available on DevOps.com. Just look in the on-demand section in the webinars page, and it will be there. Our 4 Amazon gift card winners for today are Arun K. Congratulations. Joel H. Dan L. And finally, Kyle M. So congratulations to our winners. We'll be reaching out to you via email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your spam folder. Alfredo and Jim, thank you so much for such a comprehensive webinar. And thanks again to the audience for participating in the polls. And yeah, thank you very much.
Thank you.
Bye, everybody.
This is Julio Godinez signing off until next time. Be well.